Well, hello Internet, and welcome to my Seaborn video tutorial series where you're going to learn pretty much everything you'd ever want to know about Seaborn all in one video. And basically Seaborn, just to cut to the chase, is a data visualization library built on top of Matplotlib. And in the description underneath the video, if you don't know what Matplotlib is, I cover that along with everything else you could ever want to know. This is part of my data science and machine learning tutorial series. Now this is Jupyter Notebooks, which where I'm going to do everything. You can see everything that I am going to cover in this tutorial right here. And also underneath the video, you're going to find a table of contents that you can use to jump to whatever specifically you might be interested in. Now, while in Matplotlib, you often had to write multiple lines of code to create a plot, as you're going to see, Seaborn makes assumptions on what you want, which is often going to translate into getting the same exact plot with just one line of code. So it's really cool. And you install it either by using the Anaconda Environment tab, which you may or may not have if you're using Jupyter Notebooks, or you can enter any of these into the terminal. You could either say pip install Seaborn, or you could say conda install Seaborn. Okay, so either one of those is going to get everything going. Now what I'm going to do here first, just to set up everything, is to import NumPy. I'm also going to import pandas, and I'm going to import Matplotlib, and of course I am going to import Seaborn. Kind of hard to do a Seaborn tutorial if you don't do that. Going to do a couple other things here. I'm going to set it up so that my plots are going to show up directly inside of my Jupyter Notebook like this. And then I'm going to add a couple other commands for auto reloading. And you don't need to do these, but it may help you out. All right, so everything is set up. And then of course I just hit Control and Return to load everything the way we have there. Now in regards to loading data, you're going to be able to come in and load CSV files and countless other different file types that are provided through using pandas, which is what I'm using right here. So I could come in and go computer sales, which is a CSV file I've used in the past. And you can see examples of what that looks like here. And there we go. But I'm not going to be doing that. For this tutorial, just to make it super easy for everybody, I'm mainly going to be using Seaborn's built-in data sets. And you can see the type of things that are built into it just by going get data set names. And there you can see, and this don't pay attention to this. It's an error that comes up sometimes whenever we call for these data sets if we don't go and use them properly, and it doesn't know what type of parser we're using, so just don't worry about it. Okay, so there's all kinds of different built-in data sets, and I'm going to be using at least 3 or 4 of them in this tutorial series. So you may say to yourself, well, how exactly do I load one of those data sets? Well, there's a car crash data set, which I'm going to use here first. And you just go load data set, and then you type in the name for it, which is car crashes. All right, and you can see an example of what that looks like right here. So you can see these are the total number of car crashes. This is states, so Alabama, Alaska, Arizona, Arkansas, California. The total number of crashes that they analyzed, whether the people were speeding, they were using alcohol, whether they were not distracted, if they had no previous accidents, and insurance premiums, insurance losses. All right, so that's what we're going to be analyzing. And also in the description underneath the video, you're going to find a Jupyter Notebook. Everything that I do here, except I'm going to include a ton of comments to help you out. So a massive cheat sheet, and of course it's all free because it's on GitHub. All right, so now I want to talk about the different distribution plots that are available to you. And the very first plot we're going to look at here is what we call a distribution plot. And basically what they're going to provide is a way to look at univariate distributions. And you may say, what's a univariate distribution? It's just going to provide a distribution for one variable. And how you get them is, say, SNS and distribution plot, and it's distribution plot, And of course, you can go and find out more information about this specific command by just going Shift and Tab, and it'll show you all of the different information in regards to what is available for you in regards to attributes and such. And I'm going to cover some of these things, and some of them I am not. I'm going to try to get in a happy medium of providing what you're going to use a lot versus getting into every single thing and that you're not going to use. Okay, so let's say we were interested in accidents in which the person was not distracted. So let's come in here, and you can see there's our plot. And this line right here is this is a histogram plot. That's what this is called. And what this plot is here is what is called a kernel density estimation. And if you come in here and you don't want that on there, you can just come in and say KDE is equal to false. And see there, it's gone now. And basically, it's just going to provide an estimation of the total results in your data set. All right, so pretty simple stuff. And what else can we do here? We can also define bins. So we can say bins is equal to 25. See how that changes our data. And basically, a bin's like a bucket that is going to be used to divide the data up into between different intervals. So for example, if you were doing something with profits, you could say put all profits between $10 and $20 in a bucket or a bin, and it's just going to decide how many of these bars you're going to see across your data. And so that's basically a distribution plot. Now we also in the realm of distribution plots, we have things called joint plots. And a joint plot is going to be used to compare two distribution, and plots a scatter plot by default. So we can come in and go joint plot, and let's say that I would like to receive data on the x-axis that is in regards to whether the person was speeding or not, and on the y-axis in regards to whether the person was inebriated or was drunk driving. You can say data is equal to, and we're using the crash data frame. And let's say that we would like to generate a regression line. We can go kind is equal to regression, and boom. And then you can see that it went and plotted all of this crazy stuff all over this place here. You could also come in and create one of those KDE plots just by coming into the kind area and saying KDE, and see all kinds of cool types of plots we can make inside of here. And KDE again refers to kernel density estimation. And like I said before, just estimates the distribution of data. And you could also come in and create a hexagon distribution just by typing in hex like this. And there you can see how all this data is distributed and where most of the people were, the happy spot between drinking and speeding whenever they got into their accident. So all kinds of really cool stuff you can do with a joint plot. So I've been talking about KDE plots. So if you want to generate one just completely on your own, you can do that just by saying KDE plot and crash and data frame. And this is going to, let's say we wanted to find out about crashes in regards to just alcohol usage. You can see, there we go. And I'll get more into KDE plots because they are involved very often in other plots that you're going to make. And now I want to talk about pair plots. Again, still in the distribution area of plots. And basically a pair plot is going to plot the relationships across the entire data frame's numerical values. So let's create one. We can say pair plot and crash data frame. And look at all that information. So tons of information. And you can see here on the left side, we have our totals, we have speeding data. We're also going to have data on alcohol, and we're going to be comparing these columns and rows and how all of these different pieces of data are all going to play into each other in regards to generating these both on the diagonal histograms and then scatter plots everywhere else. But there are tons of things we can change here. Let's go and load another piece of data. Let's say we want to get our tips data frame. And again, you're going to load this new data with load data set and tips. And just to show you what is in the tips data frame that we have here. Basically, we're going to have our total bill, the tip amount. Who tips $1.01? I don't know. There is whether it's male or female, whether they smoke or not, the day in which this purchase was made, and whether it was dinner or lunch, and the size of the party, I believe what that is referring to. So just to work with some different data and mix things up here, let's create another plot here. So let's get rid of this, and I'm going to say SNS dot pair plot. And we're going to be using the tips data frame. And with hue, you can pass in categorical data, and the charts will be colorized based off of that categorical data. So let's say we want to get data this time in regards to the sex. You can also come in, and I'm going to get more into styling with palettes and so forth very soon. But this is a Matplotlib palette called Blues that I've used in previous tutorials. And you can see here, now everything's using the blues styling. And you can also see that the light colored dots are for male and the dark colors are for female. And you can see the plots that we're able to make there. And basically it's total bill, tip, and size, and total bill, tip, and size is the information that we're pulling up here. And I'll just talk about styling here in a second, so we can change these font sizes and so forth. And whenever we get into grids, I'm going to show you how to make these plots and then put different graphs on the top and down the diagonal and on the bottom of our grid of plots. But now I want to talk about rug plots. All right, so let's go and create a rug plot just by saying rug plot. And specifically, we're going to look in the tips data set again. And specifically, we're going to look at tip amounts. And basically, what a rug plot is going to do is it's going to plot a single column of data points in a data frame as sticks. So you see these different sticks across the bottom on this axis. And with a rug plot, you'll see a more dense number of lines where the amount is most common. And this is kind of like how a histogram is taller where values are. Instead, with a rug plot, the plot is denser where the values are more common. All right. Rug plots I don't really use very much, but I've been messing around here with all these graphs and such. And what I want to do now is focus in on styling so we can make our plots look nicer. All right, so what I want to do here first is I want to show you how to set styling for your axes and your grids. And how you do that is you type in SNS and set style. And let's say that we just choose white. And let's come in here and I'm going to create a joint plot and then I'm going to change styling on it. So I'm going to say joint plot and let's use our car crash data. So we're going to have speeding and I will do alcohol use. And the data, of course, we're going to be pulling from our crash data frame. And I'm going to do a regression plot here for this. So there you can see is our plot. And we're going to mess around with the styling here a little bit so that you can see, like, let's say I want to change the size of this plot. To do that, I can say plot and figure. And we're using the fig size that you saw in Matplotlib if you have seen it previously. And you can see that we slightly changed our size here on our plot. And another thing you can do is, well, let's show you some other different styling. You can also, this is white, you're also going to have access to dark grid. And there you can see the change there. That looks kind of nice. And the other option available, I'm going to show you all of them. You're also going to have white grid. So there's that. And you're also going to have dark. Let's throw dark inside of here. There's dark. It looks kind of nice also. And then you have ticks. And that is all of the different options that I have there. And depending upon what your data is and the palette you're using, you're going to use different grids. And some of them look nice and some of them maybe not so much. All right, so that's ticks. I'm going to just stick with ticks here for a second. So one thing is your labels and the text and everything's kind of hard to see. So how can we change our labels and our lines and other different elements to best fit and present our data nice? Well, to do that, you go Set, Context, and there's 3 options here. You can have paper. I'm going to change the font as well. So I'm going to say font scale is equal to 1.4. And there you can see the fonts changed and so forth. And then I'm going to go and also show you the other different options available. You can have paper. You can have talk. You can see that's much easier to see right there. And also you're going to have poster, which is going to be super clear as well. And you can see that is super big. And this would be like what you would use on a poster. And while talk would be what you'd use in a presentation, and paper is what you would use in like a Jupyter notebook. All right, so let's stick with paper here and see how that looks. And I think that's pretty readable. And of course, you could change your font size if you'd like to get it exactly where you would like it to be. And another thing is sometimes these different axes you have on here, these spines, are kind of obtrusive and might not really help you with your data. Well, you can also go and decide which ones to turn on and which ones to turn off by calling dspine. And let's say that you want, let's go on the left is equal to false. Whoops, accidentally hit a T there instead of an E. And you could see that we have our left axes on there. Let's set this to true. And now you see that it's missing. All right, and let's say that we would also like to get rid of this bottom one for some reason. You can also come in and say bottom, true, and now we don't have a bottom, and so forth and so on. And as you can see here, they sort of default that what happens to the left happens to the right, and what happens to the bottom also happens to the top. And of course, you can also come in and decide if you want right as well as the top spine to be showing or not. Or you could decide to not use either of them and get this layout. All right, so there's some different styling options, and I'm going to get into other different styling options as we continue, as well as talk about different coloring options through color maps that are also available with Matplotlib. But now what I want to do is talk about categorical plotting. Now with categorical plots, we're going to focus on distributions using categorical data in reference to one of the pieces of numerical data. And the first one I'm going to talk about here are bar plots. So I'm going to say SNS and bar plot. And let's go and let's analyze some information in regards to tipping for the different males and females. So we'll say X is equal to sex and versus the total bill. So total bill. And of course, we have to say where we're going to be getting our data, which is going to be from that tips data frame. And there you can see is the differences versus the sexes in regards to the total bill from our tips data. And this little bar right here is referencing variance between the males and the total bill amounts and so forth. And by default, this data is going to be aggregated based off of the mean, but you can come in and change that. So estimator is how you're going to change it. And you could base it off of the median instead. And you're going to be able to use all sorts of NumPy formulas. So this is your data based off of the median. You're also going to be able to base it off of standard deviation and variance, and also covariance with COV. And you could also make your own functions and just plug them into the estimator to change exactly how this data is going to be aggregated. And that is a rough estimate of bar plots. And now I want to talk about count plots. Now a count plot is kind of like a bar plot, but the estimator is just simply going to count the number of occurrences. And how you call it is, we say count plot, and X, let's say we want to find out the number of males and females from our data frame that we're working with. And there you can see the total number of males versus the total number of females. And like I said, you can come right after this function and click on Shift and Tab to see all of the additional options. There's hue, which we've already talked about. You can change the order, you can change the color that we're working with, and palettes and saturation. And I'm going to talk about dodge and all of these other different options as we continue down below. And you can also read about all of the different things that are available and the more specifics on all of the different parameters as well. Okay, so that's the count plot. And now I want to talk about box plots. Now, a box plot is going to allow you to compare different variables. And what it's going to do is show you the quartiles of the data. So I'll just go and print one, and then I'll explain exactly what it is showing. I kind of really like box plots. So let's say day. And what we're going to do here is see how men and women change in regards to the total bills over multiple different days. So I'm going to say Y is going to be total bill. And of course, the data is going to come from our tips data frame. And this is the first time you're going to see hue here. And this is going to reference sex, male or female. And there is our box plot. Now, like I said, the box is going to show quartiles of our data. And you can see here's a legend and so forth. Now, this bar that goes across the middle is the median. And the box is going to extend one standard deviation. That's what the box represents from our median. These guys right here are called whiskers, and they're going to extend to all of the other data aside from what is in our standard deviation, aside from those points that are considered outliers. And these points right here are considered to be outliers. All right? And basically what hue is going to do for us is provide an additional way for us to add in another category. So we're looking at the days as well as the total bills, but by putting sex in here with hue, that is also going to allow us to create multiple box plots for each of the days for the males and the females so that we can compare them. And we can see here that men tend to spend more money on Friday versus on Saturday, where women spend more money. All right? And if you want to move this, because sometimes this legend gets in the way, let's say you would want to move it. You can go plot and legend and location. This will normally almost always work. If you just type in location 0, it left it in the same place. I'm going to get more into legend here in a couple seconds. But basically, it allows you to reposition the legend so that it isn't over top of your data. And I'll get into the specifics of it after I continue on here for a little bit more in regards to our categorical plotting options that are available to us. Now, another plot that is very similar to a box plot is what is called a violin plot. And you can create one by going violin plot. And basically, it is a combination of a box plot as well as a KDE plot. So let's say we want information pretty much exactly the same. We're going to get day information and total build information. And we're going to be pulling that from our tips data frame. And let's also use hue as well so that we can get data on men and women. And this is what a violin plot looks like. Now, while a box plot is going to correspond to data points, a violin plot uses the KDE estimation of our data points to create these plots. And another thing we can do here is you can come up and throw another option in called split and set it to true, like this. And split's going to allow you to compare how the categories compare to each other. So kind of useful, and like I said, it's just going to depend on your type of data for you to find which plot is going to work best for you. And next I want to talk about strip plots, and then I'm going to get more into some styling options with different palettes that are available to you. But first, we're going to talk about strip plots. All right. So another thing we can do here is we can change our figure size to make it larger. So, and how we do this is, again, by using matplotlib. So let's say 8 and 5 is pretty big, and then we'll throw in this strip plot and see how that works out for us. And so to create one, you just go strip plot. And basically what a strip plot does is it's going to draw a scatter plot representing all the different data points where one variable is categorical. And you're often going to see them used to show different observations with a box plot that is going to represent the average distributions. So let's go x is equal to day and total, and y is equal to total bill. And again, data is going to be our tips data frame. Whoops, I got an error here. This is figure. There we are. And you can see how a strip plot is going to work out here. And one thing we can do is we can put in another attribute called jitter. And it's going to spread our data points out so that they aren't going to be stacked on top of each other. And you just say jitter is equal to true. And you see how they spread out a little bit. And let's say that we wanted to break this data up even further into men and women. Again, we're going to use hue for this. And now you can see the difference between the men and the women. And then on top of that, you can use dodge, and it is going to separate the men and women data completely. So they'll each get their own bar. All right, so there you go. There is a strip plot with many of the cool things it can do. And now I want to talk about another one of those plots that sort of combines the capabilities of multiple other plots, and it is called a swarm plot. Okay, so what I want to do here is I'm going to create a violin plot, and then I'm going to stack a swarm plot on top of it. So I'm going to say x is equal to day, y is equal to total bill, and again, data is going to be from our tips data frame. And like I said, a swarm plot is kind of like a strip plot, but points are going to be adjusted so that they don't overlap. And it sort of looks like a combination between a violin and a strip plot whenever I create it. And I'm just going to copy all of this data out of here and run it. And you cannot see it because it's using exactly the same colors for all of these different dots inside of here. But you can easily fix that just by coming in and saying color is equal to white like that. And now you can see all those different plots inside of there. All right, so kind of neat stuff. And if you just want to see it on its own, like this, well, obviously you can't have the color be white, and there you can see exactly what it looks like. All right, so tons and tons and tons of different plotting options available to you. And now what I want to do is to talk about palettes so we can make our plots look nicer. Okay, so I'm going to change the size of my plot, and I'm going to set my grid styling here as well to use a darker look, and I'm going to make it larger by getting sort of like a presentation type of look to it by calling talk. And now what I want to do is I want to create a strip plot, and let's stick with what we're kind of used to here, which is our tip data with our total bill and our data coming from our tips data frame. And let's use our hue equal to sex. And there you can see exactly how that's going to end up looking for us. Now, these different colorings that we are using here, sometimes they look great, sometimes they don't. Well, if you want to change them, what you can do is set the palette. And then you're going to find different coloring options for yourself by going to matplotlib and specifically looking for color maps. That is what we're doing. If you type in matplotlib color maps, it's going to take you to this page right here. And what you can do is there's tons of them. These are examples of all of the different color maps available to you. And if you scroll way down, you're going to see an example of them right here, the colors that you're going to get. So let's say that I wanted to get something like magma. Well, what I could do is I could come in here and I could say palette is equal to magma and run it. And you can see if that looks better for you or not. And you could try other different looks. So let's say you can also type in, this is purple, blue, green. Let's try something like AFM hot. Okay, let's try that. AFM hot. I don't know, I'm just pulling random ones off of there. And that's kind of neat looking. And of course we can change our styling here to white and so forth and so on. All right, so there's some different ways to change the coloring for your plots. And like I said before, sometimes this legend ends up in the wrong place. Well, very often you can fix that just by coming in and saying plot legend and location is equal to 0. And it stayed exactly where it is. So if you want other options for where you can move it, one other thing you could do is try changing your figure size. And now it's not obstructing any of your data, at least. That's another option that's available to you. Or if you do not like the best option, which is what 0 is going to give you, you could try placing it in the upper right. And how you do that is you just put in a value of 1. So let's throw a 1 inside of there. Now it's in the upper right. Let's say you don't like that either. You could try the upper left, which is already where it was with 2. You could put it in the lower left with 3. So we can try that. And that's still kind of obstructing. I think the upper left is definitely the best option, which was the best option. And if you want to find out all of the other different options that are available to you, you can go to Matplotlib and specifically look for PyPlot Legends. And it's going to show you all of the other different options. You also have the options of placing it specifically. Here's the options: upper left, upper right, lower left, lower right, and so forth and so on. And here are the location code numbers for all those different things. And you're also going to be able to go and put it specifically on the XY axis by using a tuple. All right. So there's a whole bunch of different ways you can style by changing palettes and changing locations for legends and so forth and so on. And up next, I want to talk about a completely different type of plot, which is called a matrix plot. All right, so first off, the first matrix plot we're going to talk about are heat maps. So let's go and do some styling here. I'm going to say that I want my figure size to be equal to 8 and 6, and I am also going to change my grid context here, background. I'm going to change this to paper. Whoops, put it in quotes like that. And I'm going to use a font scale of 1.4, which also seems to normally work. And we'll change that if it doesn't work. Okay, so to create a heat map with data, you are basically going to have to set up in a matrix format variables. And with that, let me show you exactly what I mean. So we have our crash data frame. All right, there it is. Well, what we need to do to create a heat map is we're going to have this data that is on our columns go and line up not with indexes like this, but with these columns also being used as rows. And there's two main ways to do that, and I'm going to show you how to do both of them, both of the options that are available. All right, so let's say crash, and this is going to be matrix. One way you can do it is to go and get crash data frame and call correlation function on it. And basically, correlation is going to tell you how influential a variable is going to be on your result. So that is going to create that, and I can show you exactly what it looks like. So see, now you have your columns and your rows all lining up here instead of using those different indexes. And this is exactly what is going to be used to create your heat map. And you can look at this data right here, and you can see, for example, that no previous accidents, at least in our data set, is heavily correlated with accidents, while things like insurance premiums are not. Okay, and you can also see alcohol usage is also heavily correlated with somebody being in an accident. Okay, but we were here to talk about heat maps and not looking at just basic numbers, so let's create a heat map. So I'm going to say heat map, and I'm going to be using our crash matrix, and I'm going to say that I want to add annotations, which is going to be the numbers in the center of each part of our heat map. And if you've created heat maps inside of Matplotlib, you know how much easier this is using Seaborn. And there you can see that was how quick that creating heat maps inside of Matplotlib is like 4, 5, 6 lines. This is 1. All right, and this is a color map, which comes from the Matplotlib page that I just showed you previously. See, this one. So you can use any of those different color maps, and you can see exactly how our heat map lines up. And it's basically the same sort of data, except it looks much nicer. So let's go, and I want to show you the other way to go and create the matrix. So let's go, and I'm just going to leave that be exactly the same. You're also going to be able to create a matrix by using what is called a pivot table. Why don't I just use completely different data? I'm going to go and get some flight data. I'm going to call it flights. So SNS and load data set. And the data set we're using this time is built in again. It's called flights. And there you can see. And basically what it is based off of years and months, how many people flew on airplanes. All right? And you can also see there's indexes here, and we can't go and create a heat map of this unless we come in and put what is in the columns in the rows and show how they are correlated with each other. So what we're going to do is we are going to create a pivot table. So I'm going to go and call flights dot pivot table, and it's just another way to go and get your columns, put them in rows, and correlate all the data. That's what it is. Okay, so I'm going to say that I want to create a matrix with an index of month, and I want my columns to be equal to year, and I want the actual values from our data to be passengers. You can see exactly where that comes from. All 3 pieces of data will be used. And if I run that, you can see that we went and have our months on the left side and our years across the top, and the number of passengers that flew in those specific years and months is what you see as our actual data. All right, this is very, very useful. What I want to do now is go and actually create this heat map. So I'm going to say heat map, use our flights data. I'm going to use my color map, which is the blues one that I kind of like. You can also go and separate your data by putting white lines inside of here. I'm going to go and show you what it looks like first off, though. Whoops, flights. This is just going to be SNS. We don't need that. All right, so you can see there is our new heat map based off of our flight data. But you're also going to be able to come in and put lines between the data if that makes it easier to work with. But it doesn't show up unless you come in and also define a line width. And let's try just using 1. And there you can see how it's all divided up. And you can also see that it makes a lot of sense that most of the flights take place in July and August, and also over time that more people have been flying since 1949 up to 1960. All right, so really cool information. And now what I want to do is talk about cluster maps. All right, so for the cluster maps, what I want to use is there is data that is in regards to irises and petal lengths and things like that. So I'm going to go and just use that, and that's how we load it. And basically a cluster map, let's go and actually create one, and then I'll go and explain exactly what it's showing to you. So we're going to go cluster map like this, and then just pass in iris. But first off, what I need to do here is I need to define how I want the values to be returned to me. Well, maybe I should just show you. Let's go and show you what it looks like. Okay, so here's iris. All right, so you can see the sepal. These are basically different petal leaves or lengths and widths. So they're basically petals on irises. So what I want to do is I want to divide the data based up on the different species of irises. Okay, and then go and just plot this data. Well, I need to say species is equal to iris pop species. Okay, so that's going to say how that we want to return values based off of the different species. And then I can say SNS cluster map. Sorry, I'm not a flower expert, so I really don't know the difference between all these different guys. All right, so this is what we create. And it's a little bit complicated looking, but I'm going to try to explain exactly what is going on here with this cluster map. Now, this is what we call a hierarchically clustered heat map. And what it's doing here is the distance between the points are going to be calculated, and then the closest are going to be joined. And this is going to continue for the next closest, and it's going to then compare the columns and the rows of our heat map. Okay? So let's go and look at another piece of data that you're kind of used to. So that's basically what is going on. It's sort of trying to cluster the data types or data points, I mean. So let's go and use our flight data here just to go and show you something you've already seen a little bit of. So I'm going to go SNS and cluster map and flights, and CMAP is equal to blues. And what standard scale is going to do is it will normalize the data to focus on the clustering, which is going to sort of mess up the dates, as you're going to see. Oh, and you have to have this be equal to 1. There we go. And there you can see our flight data. And you can also see that we really focused in and clustered our July's and August data. And you can also see down here that the years are no longer in order. So that's kind of the difference between the heat map. The heat map isn't going to try to reposition data to find clusters of data. It's going to sort of work with what it has, while a cluster map is going to tightly fit and cluster the data so you can see very specific patterns that are being developed. And that is some flight data and when people fly in airplanes. So pretty neat stuff. And up next, I'm going to talk about pair grids. Okay, so what do we want to do here? Well, basically, I had previously talked about pair plots up here. And basically the way the pair plot works out is you plug in the data and it gives you a whole bunch of different plots. But what happens whenever you want to get really specific control over what plots and what data shows up where? Well, that's where pair grids come in. Okay, so what I want to do here is I'm going to use iris again. And what I want to do is I want to create an empty grid system based off of this iris data. And I say pair grid and iris, and hue is going to be equal to species. So we're going to colorize based off of the species that are inside of the different our iris data frame. And then what I want to do is I want to put a scatter plot across the upper, lower, and the diagonal. So how I do that is I go iris, G, map, and then I call plot and scatter like this. And I had to go load our iris data in here as well. And I also typed in app instead of map. Okay, so this is what a pair grid looks like. And you can see it's just scatter plots everywhere. And you can also see that everything is going to line up in rows and columns, and how that data is going to interact and correlate is going to be basically laid out for us in our plot. But what would happen if we decided that we would like to put a scatter plot across, different plots in the upper and lower as well as on the diagonal? Well, I'm going to say iris, G, map, plot, scatter. And let's say I'd want to put a histogram across the diagonal. I can say iris, G, map, and diagonal, and plot, histogram. And now you can see we have a histogram, but we also have these other scatter plots still showing up here. So let's go and get rid of the scatter plot. And let's say that we want to have scatter plots show off of the diagonal in the upper and the lower part. Well, we say iris, G, and map, off, diagonal. And there we want to plot our scatter plot. And now we get our histogram that's not obstructed with a scatter plot. And we get a scatter plot in the upper as well as the lower part of our pair grid. But let's say we want to go and put different stuff on the upper part and another different plot on the lower part. Well, we can just come in. Let's just go and copy this. I don't have to type it again. So I'm going to say that in the upper part, I want to use a scatter plot. And in the lower part, just by typing in lower, I want to put in a KDE plot, which is actually part of Seaborn. So this is KDE plot, and you can see that it did exactly that for us. And if you want to see the different options that are available to you, of course, Shift and Tab, press the plus button right here, and you can look at all of the different options that are available in regards to that function. All right, so neat stuff. You can make really, really custom, awesome looking plots. Another thing we can do is we can come in here and define variables for the X and Y for our custom grid by going iris and G is equal to SNS pair grid iris, and I'm going to say the hue is going to be based off of species, and then X variables is going to be based off of sepal length, which I think that's how you pronounce it. I don't know that much about flowers, so I apologize if I'm saying that wrong. And the sepal width, and then the Y variables going to be equal to, and let's just go and copy this, and then let's change this to petal and change this to petal. And then we can say that we want to plot a scatter plot, and let's go and get rid of this part. And then we can also come in and throw a legend inside of here with add legend. And you can see we were able to create our custom plot. All right, so pretty neat stuff. All right, and up next, I want to talk about another grid, which is the facet grid. Okay, so with the facet grid, you're going to be able to print multiple plots in a grid in which you are going to be able to define your columns and your rows. So let's say I wanted to get a histogram for smokers and non-smokers with total bill for lunch and dinner. I'm going to use the tips data frame for this, and I'll put FG in there for facet grid. And then when you call SNS facet grid, and I'm going to use the tips data frame, of course. Column is going to be represented with time, and row is going to be represented with smokers. And you can see we went and created our grid-like system here. And what I want to do now is I want to pass in attributes for my histogram. So I'm going to say tips FG map and plot a histogram, and based off of total bill. And I'm going to say that I want to put this in buckets or bins of 8. And you can see it went and automatically generated those histograms for us. So pretty neat stuff. You're also going to be able to come in and let's say you want to create a scatter plot. And that's going to be total bill, and let's try tips to compare both of those as well. Oh, this is tip, not tips. All right. And there you can see we created a scatter plot. Another thing we're going to be able to do is let's go and let's get rid of this. And let's say that we would like to assign variables to different colors. We could do this. So let's have this still be the tips data frame. I'm going to have column be time. I'm going to, however, change hue to smoker. And you can also go and change the height. And then you can, let's change the height to 4. And then you can change something called the aspect, which is going to be the width based off the height. So I'm going to make that be 1, so they're going to be equal to each other. Oh, let's make it a little bit bigger. Let's say 1.3. Then we could come down and we could say tips, FG, and let's try map. And let's just stick with a scatter plot here because that makes most sense for doing some crazy stuff. So I'm going to have this be total bill and tip. And you can see there is our two scatter plots. let's go and add some different options. Like let's say I wanted dinner to come before lunch for some unknown reason. I can do that. So I'm going to say column order is equal to dinner and lunch. And let's go and change our palette as well. So we'll say palette is equal to, I'm going to use one called set1. And I'm also going to change the edge color for our dots in our scatter plot to be equal to white. And there you can see with the changes that we made there. All right, so pretty neat stuff. Now let's go and show you some other options, because this guy has a ton of options. Let's say that we would like to go and change sizes and line widths and assign different colors to markers and use different markers. These dots right here are called markers. I can change all that stuff. What I want to do is I'm going to create a dictionary. This is going to represent the size of our markers. And then I'm going to define the line width to be equal to 0.5 and the edge color to be equal to white. Okay. Then I'm going to come in and facet grid is going to be equal to SNS facet grid tips data frame. Let's have our column be equal to sex, and our hue changes are going to be based off of whether the person is a smoker or not. And let's define the height for each of these to be 4, and the aspect ratio, which will end up being the width, is going to be 1.3 again. And let's keep just adding all kinds of different crazy stuff. Let's say we want to change our hue order and have this be yes and then no for smoker. Okay, that's what that references. And then we can also change our markers by saying hue KWS is equal to dictionary, and we'll define our marker symbols to be, let's do like a upwards facing triangle with this caret symbol like this. And then let's do a downward facing triangle by putting a V inside of there like this. All right, I'm trying to figure out use all the different parameters. And then we're going to assign this dictionary worth of data in regards to the markers as well. So I'm going to say tips, facet grid, and map, and go and create our scatter plot based off of the total bill and the tip amount, and then pass in the other data that we made in regards to the markers. And there you can see all the crazy stuff we just did with both of those. All right, so if you wanted to see just about every option imaginable. And then the last thing I want to do with a facet grid is show you something kind of neat. I'm going to go and get different data again. So I'm going to go, this is attendance data. So SNS dot load data set and attention. And what this is this data frame is going to provide like scores that were taken for different students based off of the level of attention they were able to provide during the testing phase. So it's just kind of weird sort of stuff. And so I'm going to go SNS. I'm going to create a facet grid here again. And what I want to do here is I want to put each person in their own plot with 5 per line and plot each of their scores depending upon how much attention they were able to pay during the testing phase. Okay, so it's kind of just a neat way of playing around with data. So the column is going to be the subject. I'm going to say that I only want 5 subjects per line. So column wraps 5. And I'll define the height to be 1.5. And then what I'm going to do is do a regular traditional plot. So I'm going to say TT, FG, map, and just do a regular plot. And we'll have solutions and scores. And then we can also define custom markers. So we'll say our custom marker in this situation is going to be a very simple dot. Oh, and I typed in column wraps instead of column wrap. And scores, this should be score, and run it. And there you can see all the individual subjects or students that were being tested, their scores, and how their scores changed depending upon how much detention they could pay. All right, so just so many different ways to look at and play with data. And to finish up this tutorial, I want to talk about something you're going to use all the time, which are regression plots. Okay, so I'm going to use my tips data here again. So let's go and let's just get the first 5 of these guys, just to remind you what type of data we're going to be using there. Okay, so what I want to do is I'm going to define the size of the figure to be figure size is going to be equal to 8 by 6. I'm going to set to paper for this. So set context to paper. I am going to scale my font to make this look nice to 1.4. And to plot a regression plot, which I've talked about a lot in my previous tutorials, you use LM-plot like this. And what I want to do here is I want to study whether the total bill is going to affect the tip amount. So of course it is, and that's the reason why we're doing it. So I'm going to go and plug in the total bill amount. And for Y, we're going to plug in the tip amount. Hue is going to be used to show the separation between the men and the women. So we'll say hue is equal to sex, and the data, of course, is going to come from my tip data frame. So tips data frame. And I'm going to use custom markers again, just to show you that you can. So I'm going to use a circle. And then I'm going, well, make sure you put that in quotes though, circles. And then for the women, I'm going to have uppercase triangles. And then I am going to also go and make further changes to our scatter plot by going scatter underscore KWS is equal to, and I'm going to define the size for my markers. And that is going to be, I'm going to make it 100, see what that looks like. I'm also going to define the line width, and let's make that be equal to 0.5. And I'm also going to change the edge color, and let's make that be white. And if I run it, you can see there is our highly customized scatter plot. And you can go in there and take all the other things we've learned about over the course of this tutorial and play around and make it look the way that you think would look best. And for the final thing, I'm going to do another regression plot here. But what you can actually do is you can separate the data into separate columns. So I'm going to go SNS LM plot, and I'm going to have this be equal to total bill again, and the tip amount. So we're making the same analysis here. So here's tip, and the column, I'm also going to be analyzing sex, and you can also go and separate this into time of day. So I'm going to have the row based off of that, and then finally put in your data frame you're working with. And you can see how all of that data is playing out and how it affects our regression. And it just provides you multiple different ways to look at multiple pieces of data. And if you don't like the way that looks, sometimes you can just play around with the context. So let's go and take this guy and let's throw it down inside of here like that. And let's change it to poster instead. Oh, that's very, very big. So that's not working. So let's just stick with paper. And that's pretty readable. And then of course you could also come in and play around with the heights and so forth and the widths. And let's just go and play around with height. Let's go and first off, let's move this out of here. There's a lot of space there. Let's define our height to be equal to something like 8 and our aspect to be something like 0.6. And there you go. So there's different ways we can stretch our data and look at it and analyze it and present it for our viewers. And there is a pretty thorough overview of all the different awesome things you can do with Seaborn. More visualization tutorials are coming, And like always, please leave your questions and comments down below. Otherwise, till next time.